Hello everyone, myself Vinay Kumaram. I am actually pursuing PhD in physics. So in this particular YouTube channel, I will be teaching physics, chemistry and mathematics starting from 8th standard till 12th standard. So if you want to learn physics, chemistry and mathematics, then please do subscribe to my channel. So I was actually teaching the 12th chapter of 8th standard mathematics, that is factorization. So in this particular factorization, there are three parts. So this is the third and the final part of this particular chapter. So in my previous videos, I have explained how to factorize a particular number and how to factorize a particular algebraic expression, and also how to factorize an algebraic expression using different identities. So in this particular part, we will be actually learning how to perform division between a monomial and a monomial, polynomial and a monomial, and polynomial by a polynomial. So what do you mean by monomial? So if an algebraic expression has only one particular term, then that particular algebraic expression is a monomial. For example, if I take 2y as my example, then here you can clearly see there is only one term. So this is actually a monomial. Even 2xy will also be a monomial, because here also this is a single term and it is an algebraic expression. Here two variables are there, but they are multiplied with each other. So that's why this particular term is considered as a single term and this is a monomial. So if you come to binomial, even in binomial you will be having algebraic expressions, but there will be two terms in a particular equation. So for example, 2y plus 3x is there. This particular example can be given for binomial. That means here you can see two terms are there in this particular algebraic expression. So in trinomial there will be three terms. Let's say 2y plus 3x plus 6z. So this is actually a trinomial where there are three different terms. So for example, if I take 2y plus 3y plus 6y, can this be a trinomial? No, because here you can clearly see there is a single variable, like all these three terms have y in it. So you can easily perform addition between these 2, 3 and 6. So 2 plus 3 is 5, 5 plus 6 is 11y. So this particular algebraic expression, I can reduce it to 11y. So again it will become a monomial. Any algebraic expression which is binomial and trinomial or greater than that, then that is actually known as polynomial. So here binomial is also a polynomial, trinomial is also a polynomial. Now how to divide monomial with a monomial? So monomial divided by a monomial. So let us take an example to understand this. So 6x cube is one particular monomial, divided by 2x is another monomial. So here 6x cube can be written as 6 into x into x into x, and 2x can be written as 2 into x. So when you take 6x cube divided by 2x, then that will be equal to 6 into x into x into x divided by 2 into x. Here x gets cancelled, 2 ones are 2 threes are. X into x will be x square. So the answer will be 3x square. So you should split that particular term and then see which and all terms are there which you can cancel with the denominator. But if it is a binomial or if it is a trinomial, then you cannot straight away cancel. You should take common among all those terms. I'll explain that also in next examples. So next we will look at polynomial divided by a monomial. Polynomial divided by monomial. So let us take one example. 4y cube plus 5y square plus 6y. This is one particular trinomial or a polynomial. This you should actually divide with 2y. Now you cannot straight away cancel this particular y or these particular y's which are there on the numerator. You should actually separate the common terms which are there in all these three terms, and then only you can actually cancel that particular y or that particular term with the denominator. So 4y cube plus 5y square plus 6y can be written as 4 can be written as 2 into 2, y cube can be written as y into y into y. So this is first term, plus 5y square can be written as 5 into y, this is second term. 6y can be written as 6 into y, this is third term. And 2y can be written as 2 into y. So now when you perform division between these two algebraic expression, that is 4y cube plus 5y square plus 6y divided by 2y, then here I have written this particular algebraic expression as 2 into 2 into y into y into y plus 5y square I am writing it as 5 into y plus 6y I am writing it as 6 into y, or this particular 6 can be written as 2 into 3 into y. So this particular 6y can be written as 2 into 3 into y also. So now divided by 2y is there. In all these three terms you can clearly see y is there as common. Here also you can see y is there. Here also you can see y is there. So you can take y common in all these three terms. When you take y common in all these three terms, inside bracket you will have this 2 into 2 into y, that is actually 4y square, plus when you take 1y common from this 5y square, then you will be having 5 and y remaining inside. So 5y plus here 6 will be remaining as it is. So when you perform division with this, divided by 2y. So you have 2y in the denominator. Now y and y gets cancelled. Here you cannot cancel this particular y with this particular y's. But when you take common among those three terms which are there on the numerator, then you can perform division between numerator and denominator. That is, you can cancel this y and this y. Now you have 4y square divided by 2, because this 2 will be divided by all these three terms. So this 2 actually divides all these three terms. So 4y square by 2 plus 5y by 2 plus 6 by 2. So here 2 ones are 2 twos are 4. Here it cannot divide. 2 cannot divide 5. So here 2 ones are 2 threes are. So the final answer will be 2y square plus 5 by 2 into y plus 3. So this is the answer for this particular polynomial divided by a monomial. So always when you actually divide a particular polynomial, at that particular time you should take whatever common elements is there in those terms which are there in that particular polynomial, and then only you can perform division. Even if you are doing polynomial divided by a polynomial, at that time also you should take common terms which are there in one particular polynomial which is there on the numerator and one particular polynomial and you should take common terms in the polynomial which is there in the denominator. Then you should see through that those common terms are getting cancelled or not. Then only you can perform that particular division, or else you should just keep that particular polynomial divided by polynomial as it is. I'll solve an example for polynomial divided by a polynomial. So let us take one particular example for this. So 44 into x power 4 minus 5x cube minus 24x square is one particular polynomial, divided by 11x into x minus 8 is another polynomial. Here you can see in this particular polynomial you have x power 4, 5x cube and x square inside bracket. So you can actually take x square common in all those three terms. So when you take x square common among all those three terms, so x square will come outside bracket. So 44x square. Inside bracket, when you take x square from this x power 4, x square will be remaining. And when you take x square common from this x cube, only x will be remaining, because x square into x will be x cube, minus 5x will be there inside bracket, minus 24 into x square is there. Now you have taken x square outside, so only 24 will be remaining. So minus 24 divided by 11x into x minus 8 is there in the denominator. Now you can actually perform the division. So always you should take common among the terms which are there in the polynomial and then you should perform division. So here you can see 1x can get cancelled in x square with the 1x present in the denominator, and 11 is there, so 11 ones are 11 fours are 44. So the answer what you are getting is 4x into inside bracket you have x square minus 5x minus 24 divided by, since you have cancelled this particular x and 11, now you have only x minus 8 in the denominator, so x minus 8. So now you can see inside bracket there is x square minus 5x minus 24. So if you remember my previous video, or if you have visited my previous video, there I have explained how to use identities to actually factorize a particular algebraic expression. Now you should actually factorize this particular algebraic expression which is there inside the bracket, and you should see whether it will get cancelled with x minus 8 or not. The last term which is there in this algebraic expression is not a perfect square and minus sign is there. So here you cannot use a plus b whole square or a minus b whole square formula. Let us try to use x plus a into x plus b formula. So what is x plus a into x plus b? X plus a into x plus b is x square plus x into a plus b plus ab. Now let us actually write this particular algebraic expression in this particular form. We'll try to write like that. So 4x, inside bracket you have x square minus 5x minus 24. So x square plus x, inside bracket you can actually write this as 3 minus 8, because when you do 3 minus 8 it will become minus 5. So minus 5 into plus x will be minus 5x. So the same minus 5x what is there you will be getting. So I can write this minus 5 as 3 minus 8 and x will be there as it is. So plus x into 3 minus 8 minus 24 can be written as, or plus 24 can be written as 3 into minus 8, because minus 8 into 3 will be minus 24, whatever it is there in this particular algebraic expression. So now divided by x minus 8. Here you can clearly see 3 minus 8 can be written as 3 plus of minus 8. So that means here 3 acts as A, minus 8 acts as B in this particular expression. So you can straight away write this particular algebraic expression as x plus a into x plus b. Here x remains as x, a 3 acts as a, minus 8 acts as b. So x plus 3 into x minus 8 or x plus of minus 8, that will become x minus 8 divided by x minus 8. So here you can see one factor is there, that is x minus 8, and here also in numerator one factor is there, that is x minus 8. So this particular x minus 8 and this particular x minus 8 gets cancelled each other, and 4x into x plus 3 will be remaining. So 4x into x plus 3 is the answer for this particular polynomial divided by a polynomial example which we have taken here. So let us solve exercise 12.3 which is there in this particular chapter. Coming to the first question in this particular exercise 12.3, there you have 5 different questions in that particular first question. I will be solving just 2 questions because all 5 questions are very easy. So I will just solve 2 questions and remaining 3 questions you can actually similarly solve like that. So coming to the first question, there you have 28x power 4 divided by 56x. So here 28x power 4 can be written as 28 into x into x into x into x divided by 56x. So here 1x and 1x gets cancelled with each other. So here 56 can go with 4. So 4 1s are 4. 1 will be remaining 16. 4 4s are 16. Here 28 is there. 4 7s are 28. So 7 by 14 is there. So 7 1s are 7. 14 7 2s are 14. So here 1 into x into x into x will be remaining on the numerator. So that will be x cube divided by, here x has got cancelled, only 2 is there. So x cube by 2. So this is the answer for first question in this particular first question. So coming to the fifth question in this particular first question, there you have 12a power 8 b power 8 divided by minus 6a power 6 b power 4. So we have 12a power 8 b power 8 divided by minus 6 a power 6 b power 4. So I have actually taught you different identities in exponents and power chapter, where a power m divided by a power n is there. Then if base is same, that is a is the base here, then you can easily subtract this particular power values. So here a power m minus n will be there. So a power m divided by a power n is equal to a power m minus n. So using this particular identity, so if you want explanation for this, you can refer my exponents and powers video which I have uploaded. So here you can clearly see a power 8 is there, a power 6 is there. So here same base is there. Here b power 8 is there, b power 4 is there. Here also in these two same base is there. So straight away you can write this as 12 divided by minus 6 into a power 8 minus 6 into b power 8 minus 4. So when you perform 8 minus 6, it will be 2. When you perform 8 minus 4, it will be 4. So 12 by 6 is there. So 6 ones are 6, 6 twos are 12. Here minus is there. So it will be minus 2 into a power 8 minus 6 is a power 2 into b power 8 minus 4 is b power 4. So minus 2a square b power 4 is the answer for this fifth question in first question. Coming to the second question, here also you have 5 questions. I will be solving 2 questions because all these questions are very easy. You can easily split the terms and you can actually divide that particular term with the monomial which is given in the denominator, because this second question is related to polynomial divided by a monomial. So coming to the first question in this particular second question, there they have given 5x square minus 6x is one particular algebraic expression divided by 3x. So this particular 5x square minus 6x you can take on numerator, that is 5x square minus 6x divided by 3x. You can take x common in these two terms. So when you take x common in these two terms, 5x will be remaining inside bracket, minus 6 will be remaining inside bracket. Because when you remove x from this 6x, only 6 will be remaining. When you remove x from this 5x square, 5 and x will be remaining. So x into 5x minus 6 is there, divided by 3x. So here 1x gets cancelled with each other. So this will be 5x divided by 3, because this 3 divides both 5x and minus 6. So 5x divided by 3 minus 6 divided by 3. So 3 ones are 3 twos are 6. Here 5 by 3 x is there. So 5 divided by 3x minus 2. So you are getting here 5 by 3x minus 2 as your answer. Or you can write this as 1 by 3 into 5x minus 6 as well. You can just express the answer in this particular format as well. So coming to the fifth question in this particular second question, there they have given p cube q power 6 minus p power 6 q power 3 divided by p cube q cube. So this is one particular algebraic expression and you should divide that with p cube q cube. So here you can clearly see p cube you can take common in both and q cube you can take common in both. So when you take p cube and q cube common, then only q power 3 minus p power 3 will be remaining inside bracket, because when you take p power 3 outside there will be no p inside. So when you take q power 3 from this q power 6, only q power 3 will be remaining. Here also when you take p power 3 common from this p power 6, only p power 3 will be remaining inside bracket, divided by p power 3 into q power 3. Here you can clearly see p cube gets cancelled, q cube and q cube gets cancelled with each other. So only q cube minus p cube will be remaining. So this is the answer for fifth question in this particular second question. Coming to the third question in this particular exercise, here also you have 5 questions. I will be solving 2 questions. So coming to the first question in this particular third question, there you have 10x minus 25 divided by 5. So here you can clearly see you can take 5 common from this 10 and 25. So when you take 5 common from this 10 and 25, it will be 2x minus 5. Inside bracket you will have 2x minus 5. Because 5 into 5 will be 25, 5 into 2 will be 10. So same 10x minus 25 will be getting. So 2x minus 5 will be there inside bracket, divided by 5. Here 5 and 5 gets cancelled, only 2x minus 5 will be remaining. So this is the answer for first question in this particular third question. So coming to the fifth question in this particular third question, there they have given 96abc into 3a minus 12 into 5b minus 30. This is one particular algebraic expression, divided by 144 into a minus 4 into b minus 6 is there. So this is one particular algebraic expression. Now we will write this as 96abc. You can take 3 common from this 3 and 12. So when you take 3 common from this 3 and 12, it will be into 3, a minus 4 will be remaining inside bracket. So when you take 3 common from this minus 12, only minus 4 will be remaining, into when you take 5 common from this 5b minus 30. So here also 5 is there, here also 30 is there. You can take 5 common from this. So 5 when you take common, b minus 6 will be remaining inside bracket, divided by 144 into a power into a minus 4 into b minus 6 is there. So divided by 144 into a minus 4 into b minus 6. Here you can clearly see b minus 6 and b minus 6 gets cancelled with each other. A minus 4 and a minus 4 will get cancelled with each other. So 3 will be remaining, 5 will be remaining, 96abc will be remaining. 2 sevens are 14, 4 is there, 2 twos are 4. So in this 96, 2 fours are 8, 1 will be remaining 16, 2 eights are 16. So again this can go with 2. So 2 threes are 6, 1 will be remaining, 12 will be there. So 2 sixes are 12. Here also 48 can go with 2 24s are 48. Again this can go with 2. So here 12 will be there. Here 18 will be there. Again this can go with 2. Here 6 will be there. Here 9 will be there. Here you can see 3 is there. So 3 ones are 3, 3s are 9. So here in numerator 6 is there. 5 is there. So what is 6 into 5? 6 into 5 is 30. And this A, B, C is also there. So 30 A, B, C divided by, in denominator 3 is there. So 30 A, B, C divided by 3. Again this can go with 3. 3 ones are 3, 10s are 30. So 10 A, B, C will be remaining. So 10 A, B, C is the answer for this fifth question in third question. So coming to the fourth question, here also you have 5 questions. I will be solving 2 questions among those 5 questions. So remaining 3 questions you can solve accordingly. So coming to the first question in this particular fourth question, there they have given 5 into 2x plus 1 into 3x plus 5 is one particular algebraic expression divided by 2x plus 1 is there. So this is another algebraic expression. So let us write this 5 into 2x plus 1 in the numerator into 3x plus 5. So this will be in the numerator only, divided by 2x plus 1 in the denominator. So here you can clearly see 2x plus 1 and 2x plus 1 gets cancelled with each other. So 5 into 3x plus 5 will be remaining as the answer for this first question in fourth question. So these questions are all very easy and you can solve more number of questions so that you will not get confused in between while solving these kind of questions. So coming to the fifth question in this particular fourth question. So there they have given x into x plus 1 into x plus 2 into x plus 3 as one particular algebraic expression divided by x into x plus 1 as another algebraic expression. Now we will write this x into x plus 1 into x plus 2 into x plus 3 in the numerator divided by x into x plus 1 in the denominator. So here x and x gets cancelled with each other, x plus 1 gets cancelled with each other. So you will be getting x plus 2 into x plus 3 as your answer for this particular fifth question in fourth question. Coming to the fifth question in this particular exercise, there you have 7 different questions. I will be solving 4 questions out of 7. So remaining 3 you can actually solve accordingly. So coming to the first question in this particular fifth question, there they have given y square plus 7y plus 10 as one particular algebraic expression divided by y plus 5. Here, before writing this in the form of numerator divided by denominator, first try to factorize this particular algebraic expression, first algebraic expression. So you have y square plus 7y plus 10. Here you can clearly see 10 is not a perfect square, so you should actually use x plus a into x plus b formula. So what is x plus a into x plus b? So x plus a into x plus b will be x square plus x into a plus b plus ab. So this is the algebraic identity which you should actually use to solve this particular algebraic expression. So this y square plus 7y plus 10 can be written as y square plus 7 can be written as 5 plus 2 into y plus 10 can be written as 5 into 2. This is in the form of x square plus x into a plus b plus ab. Here in the place of x you have y, in the place of a and b you have 5 and 2. So this particular algebraic expression can be written as x plus a into x plus b form, that is actually y plus 5 into y plus 2. So this will be your numerator value. So in the numerator you will be having y plus 5 into y plus 2, and in the denominator they have given to divide this particular algebraic expression with y plus 5. Here y plus 5 gets cancelled with each other, so y plus 2 will be remaining. So this y plus 2 is the answer for first question in fifth question. Coming to the third question in this particular fifth question, there they have given 5p square minus 25p plus 20 divided by p minus 1 is there. So you can actually factorize this particular expression. So before factorizing you can actually take 5 common among all these 3 terms. So when you take 5 common in these 3 terms, you will be having p square minus 5p plus 4 inside bracket. So this acts as one particular algebraic expression. This you can write it as x plus a into x plus b. So 5 into p square minus 5 can be written as plus minus 4 minus 1 inside bracket into p. So when you do minus 4 minus 1, it will become minus 5 into p is there. So minus 5p will be there. So plus 4 can be written as plus into minus 4 into minus 1. Because 4 into 1 will be 4, minus into minus will be plus. So plus 4 you will be getting back. So here this particular algebraic expression can be written as x plus a into x plus b form. Because here minus 4 acts as a and minus 1 acts as b. So 5 into p acts as x. So p plus of minus 4 into p plus of minus 1 will be there. So that is actually 5 into p minus 4 into p minus 1. So now you can write this in the numerator. So 5 into p minus 4 into p minus 1 will be there on the numerator, divided by in the denominator p minus 1 will be there. So p minus 1 gets cancelled with each other. So 5 into p minus 4 will be remaining as the answer for this particular third question in fifth question. So coming to the fifth question, in this particular fifth question, there they have given 5pq into p square minus q square as one particular algebraic expression, minus 2p into p plus q as another algebraic expression. Here you can clearly see this particular p square minus q square is in the form of a square minus b square for identity. So 5pq into p square minus q square can be written as p plus q into p minus q, because a square minus b square will be equal to a plus b into a minus b. So here it will be p plus q into p minus q in the denominator. So this is actually divided by 2p into p plus q. So in the denominator you will be having 2p into p plus q. So here this p plus q gets cancelled with each other, p and p gets cancelled with each other. So you will be having 5 by 2 q. So 5 by 2 into q into this particular p minus q. So p minus q. So 5 by 2 q into p minus q is the answer for this fifth question in fifth question. So coming to the seventh question in this particular fifth question, there they have given 39y cube into 50y square minus 98 as one particular algebraic expression, divided by 26y square into 5y plus 7. So in this particular algebraic expression, you can take 2 common from this 50 and 98. So when you take 2 common from this 50 and 98, so you will be getting 39y cube into 2. So inside bracket you will be having 25y square minus 98. When you take 2 common from it, 49 will be remaining inside bracket. So here you can clearly see 25y square is there, minus 49 is there. So 39y cube into 2 will be there outside bracket, into 25y square can be written as 5y whole square minus 49 can be written as 7 square. So here you can clearly see a square minus b square form is there. So you can directly apply the identity for this. So 39y cube into 2. So 5y square minus 7 square can be written as 5y plus 7 into 5y minus 7. So this will be there on the numerator. So 39y cube into 2 into 5y plus 7 into 5y minus 7 will be there on the numerator. So in the denominator you can write the given algebraic expression there. So 26y square into 5y plus 7. So here 5y plus 7 can get cancelled with each other. So here 2 1s are 2, 13s are 26. So this 13 can be cancelled with this particular 39. So 13 1s are 13, 3s are 39. So what and all things are remaining? Here y cube is there, here y square is there. So 3y cube into 5y minus 7 will be there on the numerator, divided by y square will be there on the denominator. So here y cube is there, here y square is there. So here y cube can be written as y square into y. So y square gets cancelled and only y will be remaining. So 3y into 5y minus 7. So 3y into 5y minus 7 is the answer for this seventh question in this particular fifth question. So this was the part 3 video of factorization. So here factorization chapter gets completed. So like this I will be uploading more physics, chemistry and mathematics videos related to 8th standard, 9th standard, 10th standard, 11th and 12th standard. So if you want to learn physics, chemistry and mathematics, then please do subscribe to my channel and stay tuned with my channel. Thank you.